Okay, here we are at the bottom of page 4 for the notes. Let me just note that for those of you that are skipping around a little bit. This is 1.1, page 4. And application exercises is a fancy way of saying that we're going to tackle some word problems, some story problems. Very important. Build those critical thinking skills, your reading skills, your comprehension, your critical, your observation, your translating skills. All this comes into play when you start doing application exercises. That read, breathe, read again is going to be critical for this. Now you may want to pull out your book to kind of look at this one. The printing is a little small to make it all fit on this page, but we're going to tackle number 84, and you'll see some similar to this in the practice assignment from the book. One thing to notice is sometimes, you know, the book, your eyes will go right to the number 84 in the book, but then as you read it, you go, I don't see all the information I need. This book tends to, just above the one you're working on, put the graph or the information that you'll need. So watch for that, okay? So here, in 2006, 60 years after Jackie Robinson broke the sports color barrier, only 8% of Major League Baseball players were African American. The bar graph shows the decline in the percentage of African American Major League Baseball players from 1997 through 2006. So we've got 1997 through 2006, percentages go up the top, and then they did a bar graph and they gave the value for each: 17, 15, 13, 13, 10, 9, 9, 8. So there's kind of a decrease here. This is the actual data. The graph shows the actual data. Okay. Then they give you what's known as a mathematical model, or they might call it a formula, or a mathematical function, or a model like they refer to here. Here's a mathematical model that approximates. So this is the actual real data here. But over here, this is approximate the data displayed by the bar graph. If you were to kind of squint your eyes a little bit and go, okay, over time it kind of looks like it's decreasing. It kind of looks like it's following this line down here. It's not exact, but it's sort of. That's where they're getting this model. How do they do this? And this is one of our focuses for Math 60. We're going to arrive at the point where we can connect a line to an equation and an equation back to a line. That's going to be our big payoff here for Math 60. So we're being handed it right now, and we're going to play with it a little bit here. Okay, so the mathematical model is p equals 16 minus n, and they tell you what the two variables stand for. The n represents the number of years after 1997, and p represents the percentage of African American Major League Baseball players. Now let's see what the problem asks us to do. Use the formula to find the percentage of African American players 8 years after 1997, or that would be 2005. And then it asks you the question, does the mathematical model underestimate or overestimate the actual percent shown by the bar graph for 2005, and by how much? So what we're going to do is we're going to use the formula, which is this right here, the p equals 16 minus 9, and we're going to put in a value for n. N equals 8 years after 1997. So we don't put in 2005. N represents the number of years following 1997. So if they told us, hey, do it for 2005, we'd subtract 1997, get 8. N equals 8. They tell us it's 8 this time. So we're going to plug in, we're going to evaluate P for N equals 8. So P equals what when you have N of 8? So we're going to put 8 into the model. P equals 16 minus N, and we get P is equal to 8. So according to the model, this is what the formula gives us, 8% would be the answer. Now, does the model underestimate or overestimate the actual percent? So now we look at 2005 on the graph, and 2005 is right here. In 2005, the real data says 9%. 2005 is 9%. So the model actually underestimates the real data. Okay, by how much? I should do another color there. By how much? Whoops, my pen slipped a little bit, by 1%. Okay. Sorry, it's hard for me to write up against the edge here, so I'm moving it around a little bit on you. Now let's look at part B. Use the formula again. Use the formula to find the percentage of African American players in 2000. How well does the model describe the percent in the bar graph for this year? Now, the difference between part A and part B is part A, they gave us a year and the number that that would represent for in the years after 1997. In this case, they just give us the year. So the year is 2000, and that's equal to 3 years after 1997. 2000 minus 1997 equals 3. So our in value in this case is 3. So let's take now P equal to 16 minus our in value, which in this case is going to be 3. Because again, we're comparing the model to the graph. Okay? And this is what math does. Math looks for patterns in real life and seeing if we can use it to predict it. Now, sometimes it works, sometimes it doesn't, because real life is very unpredictable. But sometimes we can see a trend. Okay? So that's what I want you to keep straight, the difference between real life data and a model, a mathematical model. We can kind of see a pattern, but there's nothing to say that in this next year it doesn't shoot back up. Okay, because life can be unpredictable. But if the trend continues, what could we expect? But right now we're just comparing the model to the real data here. So the model here, P equals 16 minus 3, we get 13 or 13%. And let's look at the year 2000 on the graph. I think I should use a different thing here. So 2000 on the graph actually was 13% as well. So it's right on, okay? So how well does it describe the percent? It's perfect. The model sometimes does a great job. The model sometimes will overestimate or underestimate. That's why it's just a model. It's not an exact representation of real life. Okay, and that should be enough to get you going on section 1. Again, the notes and the examples, whether you follow along in class or use the video notes or both, it's meant to get you started. You're going to have to apply your thinking skills and push yourself to let the practice problem set grow you and challenge you and build those thinking muscles that you're going to need to survive, both in life and then specifically in this class this term. Okay? All right, we'll see you in section 2.